This is Honors Geometry. We're going to do volume and surface area of composite solids. So we're going to jump right in. Composite solids means you're either going to add two solids together, or you're going to subtract one from another one. Volume's a little bit easier than surface area, so we're going to start with volume. So you just have to ask yourself, are you adding two volumes together, or are you subtracting? And then you just go ahead and go about the formulas like we're used to. Looks like I have a cone and a cylinder, and I'm going to add them together. So we know the volume of a cone is 1/3 area of the base, which is a circle, so that's pi r squared, times the height. And then to that, we're going to add a cylinder, which is area of the base, which again is pi r squared. And then we're going to multiply it times the height. We don't need the third there. So let's go ahead and substitute in our radius. Our radius we're given is 3. And the height of our cone is 3. And then to that we're going to add the cylinder. And the cylinder has the same radius, which is 3. And the cylinder has a height of 7. So that's it. We simply punch that in our calculator. We got our answer. Let me go ahead and do that. So I have 1/3 times pi times 3 squared times 3 plus pi times 3 squared times 7, and it looks like we're looking at about 226.2. Does it tell us how to round 2 decimal places? So we'll go 226.19. And that would be cubic centimeters. All right, the next one we're going to be subtracting. We can see there's a hole in our cube. So we're going to subtract this time. So the first one is a cube, or if you want to call it a rectangular prism. So volume is going to be area of the base, which is 10 times 10, times the height, which is 10. And then to that, we're going to be subtracting. It looks like we have a pyramid cut out of our cube. So I'm going to subtract. And they're showing us that all these are congruent. And we can see the two of these together equal 10. That means each of them are 5. And we know this is a right angle because it's a cube. So we're going to do the Pythagorean theorem, and we're going to see what the base of our pyramid is. So I'm going to say 5 squared plus 5 squared equals c squared. So that's 25 plus 25 equals c squared. So we're looking for the square root of 50. So let me punch that in and see what it is. So we're looking at 7.07. We'll go out 2 places. So we know this is 7.07, and they're all going to be that because we can see they're all congruent. They're written as congruent even though it looks a little skewed. So from that we're going to subtract a pyramid. So it's a pyramid, so I have 1/3, and then the area of the base, which is 7.07 times 7.07. And then we're going to multiply that times the height. It looks like the height is the same as our cube, so we're going to multiply that times 10. And let's see what we get. We have 10 times 10 times 10, or 10 to the 3rd power, minus 1/3 times 7.07 times 7.07, and then times 10. And it looks like we're looking at about 833.38, and that would be cubic inches. All right. And the last one, it looks like we have a cone on top of a cone, so we would just add those two together. All right, let's go ahead and do surface area. Surface area is a little bit more work because you have to figure out what's missing. So it looks like we have a cone on top of a cylinder again. But this time we have no bottom to our cone, no top to our cylinder. So if this were one of those little coin banks that you had as a kid and you dropped a coin in, it would drop all the way to the bottom. There's no material between the cone and the cylinder. So we're going to have to adjust our formulas accordingly. All right, so here we go. Surface area of our cone is area of the base. We don't have the base, so we're going to take that off. So then it's going to be pi times the radius, which they're showing us is 5, times the slant height. Oops, they don't give us the slant height. They're showing us the height is 4 and the radius is 5. So we're going to do a quick Pythagorean theorem here. 4 squared plus 5 squared equals c squared. 4 squared plus 5 squared gives us 41, square root of 41. We're looking at about 6.4 is our slant height. Okay. If you remember, let me just back up a step. If you remember, the volume of a cone is pi r squared, that's the base, plus pi r L. So we're just going to go with pi r L. We don't need the base. And surface area of a cylinder is 2 times the area of the base. We only have one base. There's no top to our can. So instead of 2, we're going to have 1 pi r squared. And then we want the circumference of our circle, of our base. Let me just get rid of this so I have some room to work. So that's going to be plus 2 pi r. That's the circumference. And then times the height. And that'll give us, if we peel open this can, that's a big rectangle. All right, now let's go ahead and substitute what we know. So again, we know the radius is 5. We just calculated the slant height is 6.4. And to that, we're going to add the bottom of the can of the cylinder. So that's 5 squared pi. And then to that, we're going to add the body of the can, which is circumference times height. So that's going to be 2 times pi times 5 times the height, which they're showing us is 12. Let me go ahead and punch that in my calculator and see what we have left here. Pi times 5 times 6.4 plus 25 pi plus 10 pi times 12. And we're looking at about 556. And 2 decimal places, that would be 0.06. And we're doing surface area, so that's going to be square centimeters. Let's see, which one do we want to do? Let's go ahead and do the second one. I'm going to have to erase so I have some room to work here. All right. So in this one, we have a cube. And there's a square. It tells you up here somewhere that the pyramids are regular. So we can assume that that's a square pyramid. Okay. So surface area, we'll start in the bottom this time, of a square pyramid or square prism or a cube or a rectangular prism if you want. We want the area of the base, which is 5 times 5. And then to that, we're going to add the perimeter of the base times the height to do those 4 squares in one easy step. So perimeter of the base is going to be 5 plus 5 plus 5 plus 5, or 20, times the height. Okay. So now we took care of the bottom, we took care of the lateral faces, these squares. Now to that, we're going to add the pyramid. Remember, we don't have a bottom to our pyramid. If I drop a penny in, it would go all the way to the bottom. So I'm going to take off the base of that. So I just need 1/2, because they're triangles, perimeter of the base, which is going to be 20 again, times the slant height. Again, we want the area of this triangle, so that height's not really what we want. So let's go ahead and do another quick Pythagorean theorem right here. We're going to take that 5, we're going to cut it in half and get 2.5. We know that the height is 3, that's given, so we're going to calculate the slant height, which is really what we need. Make some room to work here. So I'm going to say 2.5. I got that from cutting my side length in half, squared plus 3 squared, which was given, equals c squared. Grab my calculator here, 2.5 squared plus 3 squared gives us 15.25. Equals c squared, square root 15.25. And it looks like we're looking at about 3.91. which seems like a reasonable amount. We knew it was going to be bigger than 3. So we're going to throw in our slant height, which is 3.91. Okay, let me go ahead and just back up a little bit. This is the area of our base plus the perimeter of our base times our height. To that, we're going to add 1/2 because we're having triangles. Perimeter of our base times our slant height. And that's what we have here. Let me go ahead and punch that in my calculator. We'll get an answer. Okay, if I did it correctly, we're looking at 164.1, and that would be square inches. Okay, and this is, you're just adding two cones together. Please try the practice problems. Let me know if you have any questions. Thank you.